This is Dafika Academy. Today we want to look at integer points. This is a subtopic in Introduction to Real Analysis, which is very basic. It is very important to be noted. Okay, integer points we start with its definition. So if we let a given S to be a subset of real set, so S is a subset of real set. A point P in S is called an integer point of S if there exists an open interval, which is AB, such that you find that MB is in the open interval, which is a subset, pure subset of S, So that P is in the interval, and this interval is contained in S, is a subset of S. So if you have such kind of that particular P, it is called the integer point of S. It's called the integer point of S. So the set of all integer points of S is noted by S naught and or that or int S. So if you have all these set of all those integer points, such that integer point is in a given interval and it's also in S, then you find that that set will be integer point, set of integer points. Okay, let's look at an example. If you have this S being a subset of R, and which is a closed interval, you'll find that the set of all integer points, this will be an open set of 2, 4. So if you take any point here, NP in this NP here, NP here, yes, here, you'll find it will be in S. It will be in S. 2 is in S and 4 is in S, and then being inside there. Again, if you have this S being an open of that, you'll find again it will indeed be the same thing. So integer set will be given by the open set 2, 4. Let's look at open set. How do you define open set? So open set, a subset S of real set, is said to be open if every point in S is integer. So you find all elements in S are integer points, then you find that S is a subset of R. S then is said to be integer if and only if that the integer set is equal to the subset S of R. So if you get that condition here, then you say that will be an open set. For example, in our case here, B here, our S here is same as the set of integer points, and therefore this is a open set. Okay, let's look at an example. Every open interval is an open set, like in our previous case. Every open interval is an open set. A closed interval, it is not open, trivially. It is closed. Therefore, to mean not every integer point is in the interval, as in the case of a previous example. So it's not open. An empty set is open. Why? Because every integer point in empty set is in empty set. So since there's no point of empty, which is not empty set, which is not an integer point. So every point in the empty set is actually, or the null set is actually integer point. So if you set, we have these sets, the natural, rational, and the integer sets. You find that these ones are not open, because you'll find that the integers are not in their sets. And above, you find that the set of real numbers is open, because if you get a given point in the interval of open set, you find that it is still in the real set. And that is actually the idea of neighborhood. So kindly subscribe and share with your friends, and if you have not subscribed, okay, bye for now.